Hello, my name is Aidan Casey, and our team designed an abandoned mine drainage treatment plant for Big Mountain, where our goal is to turn acid mine drainage impacted streams into healthy streams. Shamokin Creek, spanning 32 miles, faces significant AMD inflows, and Big Mountain is where we will be focusing on this project. Historic underground coal mining has created a complex subsurface network of flooded mine workings, which has led to continuous discharge of highly acidic, metal-laden waters. These discharges flow directly into Buck Run, a tributary of Shamokin Creek, and have severely degraded aquatic habitat, impaired biodiversity, and complicated downstream water treatment. Our study emphasizes the need to safeguard the waterway and its ecosystem. Big Mountain has one mine pool, which contributes to its sole discharge point right below the creek, as can be seen here. We have decided to place our treatment system northwest of the discharge point. This location provides proximity to the discharge, relatively flat terrain, ample space, direct access to Shamokin Creek for effluent, is already zoned for industrial use, and offers convenient access to existing infrastructure, such as roads. This is ideal to save money for storage and pumping. The influent chemistry of the plant was determined with a statistical analysis based on the data provided by Tetra Tech, where it was decided that the 90th percentile would be used for design flows, and that the 50th percentile would represent typical conditions. The 90th percentile was selected because it was not significantly higher than the 75th, and therefore will allow us to ensure treatment of all effluent while retaining a cost-effective treatment system. The effluent standards were used to determine the sizing of the treatment units. A redundant treatment system for most treatment units was utilized to ensure constant treatment could be achieved. The design flow for these treatment units can be calculated with the redundant flow equation. The conceptual design for this plant outlines the initial treatment approach without committing to final unit sizing or detailed process design. Pumping and conveyance were outside of the scope of this design. The first process is decarbonation, in which we reduce the total acidity by transferring dissolved CO2 from the mine water to the atmosphere. Next is neutralization, and in this process we add caustic to the water to raise pH levels. The next step is to run the water through a clarifier, which removes suspended particles and impurities through settling. Finally, we employ a polishing pond. This will be accomplished with an aerobic wetland, which further refines the water and increases the water quality before we discharge it. The process flow diagram provides a detailed overview of the treatment process. AMDTreat was used to calculate or estimate total costs for the treatment units, with an overall capital cost of approximately $5.42 million and an annual operations cost of approximately $289,000. Overall, our focus was on the sizing and the cost analysis of treatment units using a combination of hand calculations and AMDTreat software. This approach ensures a comprehensive understanding of the project scope, which allows for effective planning and resource allocation. Thank you for your time.